So we're going to get into simplifying rational exponents, rational exponent expressions. We'll be spending 2 days on this, and then we'll spend 2 days also solving rational exponent equations too. And then we'll have our quiz on Friday, Assessment Friday. Okay, so yeah, let's get into things here. Okay, so before we get into simplifying rational exponents, okay, we're going to talk about reviewing our exponent properties first, okay, because that's super important to remember those, okay. So when we start out here, let's just answer this question. What does 4 to the third mean? So go ahead, pause the video, answer that question. What does 4 to the third mean? What does it mean to do? Okay, so hopefully you did pause the video there. 4 to the third, remember that exponent right there, it tells you how many times to multiply this base. Okay, so the big number is called the base. This is called the exponent right here. The exponent tells you how many times to multiply that base out, or multiply it by itself. So we have a base of 4, so it's going to be, and then it's being raised to the third power. So it's going to be 4 times 4 times 4. 4 times itself 3 times. And then you can simplify that, of course, if you want to. So 4 times 4 is 16, times another 4 is 64. So there's your answer. Okay, but that's super important to understand what that exponent means. So when we get down to situations like this right here, yes, you could just type in your calculator if you want to. You know, you could change this to be 16 and this to be 64, and then just multiply and get your answer there. Okay, that's one way to do it. However, there's some interesting properties that come up that allow us to simplify this a little bit easier. So again, if we think about this back in the definition, 4 squared would be 4 times 4, and then 4 cubed, well, that becomes 4 times 4 times 4. Right? In fact, maybe I should do a different color here. Let's do this. Okay, so 4 cubed becomes 4 times 4 times 4, like that. Well, if you look here, it's just 1, 2, 3, 4, 5 4s being multiplied together, so it becomes 4 to the 5th. Okay, and so that is another way you could simplify there. Okay, in other words, how did we go from a 4 to the 2 and a 4 to the 3? How does that then become a 5? Well, what do we do with a 2 and a 3 to make a 5? It's addition, right? So in other words, this is just really just 4 to the 2 plus 3 power. So when you multiply, you add your exponents. Okay? So what about this situation right here? Here we have an exponent, 2, raised to another exponent, 3. Okay, how do we simplify that? Well, again, let's use our exponent properties. So the first thing I see here is we have something, this something right here is being raised to the third power. So that means we're going to have 4 squared times 4 squared times 4 squared, right? 4 squared 3 times. But then what do those squareds mean? Well, all those 4 squareds are 2 4s being multiplied together. How many total 4s do we have? 1, 2, 3, 4, 5, 6, right? And so it's really just the same as 4 to the 6th. How can we make this 2 and 3 become 6? It's 2 times 3, okay? So when we have a power raised to a power like this, we multiply exponents. Okay, so be careful here. When you multiply, you add exponents. When you have a power raised to a power, you multiply exponents. Okay, so multiplication between the bases means you add the exponents. Power an exponent to an exponent means you multiply the exponents to simplify it. Okay, so then we get down to division here. So division, okay, division, well, a division is similar to multiplication, right? In fact, division is the opposite of multiplication. So in multiplication, what do we do with our exponents? We added, right? So in division, what should we do with our exponents? If for multiplication we add, division we should, and hopefully you said subtract. And again, I can kind of show that to you here. If we rewrite 4 squared as 4 times 4, and then we put 4 cubed as 4 times 4 times 4, right? We can cancel out these 4s in common here, leaving a 1 over a 4 like this, which is the same thing as 4 to the negative 1. But isn't that really just the same as 4 to the 2 minus 3, right? Subtracting, again, these exponents. Okay, so 4 to the negative 1, or 1/4 is another fine way to write that too. Okay, so let's take a look here though when we have some or variables, I mean. So what about these guys over here? Well, when you square a quantity, again, what does it mean to square something? It means to multiply it by itself, right? So to multiply it by itself. And so to multiply here, it will be the 4 times the 4, so 4 squared, and the x times the x, so x squared. So in other words, you can distribute a power to the two things in the product there. Okay? Notice though, x plus 2 squared does not equal x squared plus 2 squared. So be careful about generalizing too much here, okay? 4 times x, okay, when you square that, you can distribute the exponent like we did right over here. 4x squared becomes 4 squared and x squared. Okay, but in general, if we have addition, x plus 2, you cannot distribute the power to those two terms, okay? It doesn't equal that. Remember, x plus 2 squared is x plus 2 times x plus 2, which is x squared plus 4x plus 4 when you multiply it all out and combine your like terms there. And you'll notice that this is not the same as that, so be careful. Okay, be careful there. Okay, so let's take a look at the next one here. Okay, the next one, we've got division. So just like how we could distribute the power in multiplication here, we can also distribute the power in division. So it'll be 4 to the third and x to the third as well. And then it's your choice if you want to rewrite that 4 to the third. You know, just like here, you could have rewritten that 4 to the second as 16. That's fine. That's not bad. And then 4 to the third, you could have rewritten that as 64 over x to the third. Or if you want to, we also could have rewritten as 64 times x to the negative 3, right? When you have a positive exponent in your denominator, you can bring it up into the numerator if you make it a negative exponent there. Okay, so there are your refreshers on the properties. So let's use these now with our rational exponents. So in fact, the same properties are true for rational, that is the fraction exponents that we've been looking at. So let's look here at this example. All right, in this case, we have 25 times 25. Okay, so the same base, and that's important. Okay, we cannot add these exponents like we want to if we have different bases, but our bases are the same. They're both 25, so we can add those exponents together. So again, we know multiplication means that we're going to add these two exponents. Okay, so we end up with 25 to the 3/5 plus 7/5. And what is 3/5 plus 7/5? Well, again, you can use your calculator if you want to, but if you have 3/5 and you add 7 more fifths, you now have 10/5. But 10/5 is a fraction that simplifies, right? What is 10 over 5 simplified to be? It's just 2. So it's 25 squared. And if you want to, you can then multiply that out, okay? And you get 625. Of course, this whole mess you can type into your calculator if you want to, and then just simplify and get the answer. That is an option for you, okay? But you won't be able to type in your calculator with the variables when we get down here to like this guy right here or something. Okay? All right, let's try this next one. 8 to the 1/3 divided by 8 to the 2/3. Aha, division. So when we have division, what should we do with our exponents? Hopefully you said subtract. So 8 to the 1/3 minus 2/3, just like that. Okay? And again, you can just do the subtraction if you want to. You don't have to like write it out like I'm doing it here, but you know, I'm just writing it out because we're learning it right now. 1/3 take away 2/3 is 8 to the negative 1/3. Okay, which remember that's the same as 1 over 8 to the positive 1/3. So again, when you have a negative exponent, you can move that quantity into a denominator like this, leaving a 1 on top, and then having now a positive coefficient. Remember that to the 1/3 power is the same as saying what root? It's the cube root of 8, right? It's a 1, so it's really a cube root of 8 to the 1 if you like there. Okay, and so what's the cube root of 8 to the 1? Well, 8 to the 1 is just 8. And so then cube root of 8 is 2. So this is really just 1/2 when we simplify there. Again, you can type that in your calculator if you want to. Okay, I'll just show you that briefly here. So let's just say we wanted to, let's just say we wanted to do this in our calculators. 8 to the 1/3 divided by 8 to the 2/3. You can literally do that. So we just go to my calculator here. Okay, so turn it on. 8 to the, and now my calculator allows me to like put the whole fraction there. If you are concerned, always put parentheses around that fraction. It's not a bad idea. So 8 to the 2/3, arrow out, divided by, or no, it's 8 to the 1/3 divided by 8 to the 2/3. 8 to the 1/3 divided by 8, caret, again the caret's above the division sign there, and then parenthesis 2/3, and then close the parenthesis and hit enter. And voila, 1/2 or 0.5. Hit math, enter, enter. You know, convert to a fraction, 1/2 is what you get. And if we go back to my notes here, hey, look at that, we also got 1/2. Check. All right. Mr. Witt's not crazy. Well, he's crazy, but at least he's not wrong. All right, so next one here. Okay, we have a couple things going on here, so you have some options about how you simplify this. One thing you could do is go ahead and just distribute to all three terms here. So you can make this y to the 4/3 to the 3 halves, y to the 2/3 to the 3 halves, and y to the 16 to the 3 halves as well. Okay, or you could also simplify inside here first, and then you know, continue from there. Let's maybe simplify inside here first. So I see here that these two things go together; they have the same base, and so we're dividing, which means we should subtract those two exponents there. So 4/3. So this is going to be 1/16 in front there. Okay, because 1/16, and then 4/3. 4/3 take away 2/3 is 2/3, so it's going to be y to the 2/3, and they're going to raise that whole thing to the 3 halves power. So this becomes 1/16 to the 3 halves, okay, times y to the 2/3 to the 3 halves, like that. Okay, again, it just distributes to both of these things here. Okay, you can type this in your calculator if you want to, but we can also just simplify it. I mean, again, when you have a 2 in the denominator like that, that means the square root of 1/16, and we're going to then raise that to the 3rd power. Because again, 3 was our exponent there, so that becomes, or a numerator, so that becomes our exponent there. And then the 2 in the denominator becomes this root that we have right there. Okay, and then here we can multiply these two, because again, it's power raised to a power. And when you multiply 2/3 times 3 halves, if you do it in your calculator, you get just 1. Okay, so we can continue simplifying this right here. Square root of 16 is 1/4. Again, just think about the square root of 1 over the square root of 16 there to do that. Maybe like write it like that. There we go. Okay, and then you have the y to the 1. And voila, there's your answer. Of course, you could have typed, you know, 1/16 to the 3 halves in your calculator, and it would have given you that 1/4 as well. All right, we'll do one more here, and then we'll stop. So next one here, we have 27 times x to the 3/4 to the 2/3. Again, distribute, right? So it'll be 27 to the 2/3 times x to the 3/4. Maybe I should parentheses there. Raised to the 2/3 power. Okay, so 27 to the 2/3. Again, we can just simplify that. We have a 3 in the denominator of that power, so that means it's a cube root of 27, and we will then square, because again, 2 was the numerator there, so it becomes the exponent. And then here, since we have a power raised to a power, we will just multiply those powers, and so we're going to get x to the 6/12. Remember, when you multiply fractions, you multiply across the top and across the bottom. Okay, now let's simplify this right here. Okay, the cube root of 27 is 3, and we're going to square it, so that's going to give us 9. Okay, and then x to the 6/12, well, that simplifies to 1/2. And so there's our answer. If you wanted to rewrite it using a radical, you could say 9 times the square root of x if you wanted to. But I think this is a fine answer right here. Okay, so I'll get you guys your assignment on Schoology. You know, replay this video or send me a message if you need more help. Thanks, guys. Have a good day.